Hello, my beautiful students. How are you doing today? I believe everything is all right. Yes, in today's class, we want to still deal with another important aspect in mathematics. And this has to do with laws of indices. Laws of indices. Now, in mathematics, indices. For example, if I write a number like this, 10 times 10 times 10. Now, this number, we cover 10 in how many places? 1, 2, 3. This is the power of 3. So this is the short form of a number written in this form. Now we pay 10 in 10. We have 10 in 3 places. Let me tell you 10. That we call raised power of this. Now, okay, okay, ni index. At times, we need power of of 3. To ba 3 now consider as a power of 3. To ba 4 now consider power of 4. 10 raised to the power of 4. But in mathematical terms, this is an index. This is an index. Now, when you now have many of these, you will not call it an index again. You now say indices. That is plural and non indices. 10 raised to the power of 3 times 10 raised to the power of 5. This one, indices only index because plural of index is called indices. So now, we want to now talk of the law. But when you want to relate, because mathematics are very, very interesting. Now, let us now say this. This one, what you call in school, you have been taught in your various schools. Now, I want to simplify it. As I always say, I want to bring it to your fingertip. That is, mufeki or simplify, so that anytime you should be able to what? You should be able to say something. Is that understood? Get me saying so. The other one, it's more 10. This time around, they can still write only one letters. You understand? For example, if I say P times P times P times P times P. Now, class, more copy. 1, 2, 3, 4, 5. This one is something as P raised to the power of 5. That is P. Anytime this one means that one copy, one corny, a maru. Now, for example, if we share equal to Nakoi, P raised to the power of 5 is same thing as P times P times P times P times P. I think I get it. Very good. Now, one linear operation in multiplication. For example, we have multiplication. So now, multiplication. After we into one, so for example, Timbani A raised to the power of 3 times A raised to the power of 6. A ni divide. A meta at A mefa. Now, if we now add the two together, we now have A raised to the power of 9. So now, but at times, in exam, our fellow in what short form would I get it? Now, it now means this 9, but actually get it now. If I say A raised to the power of 3 plus 6, for me, A raised to the power of 9. Is that understood? For me, A raised to the power of 9. So, in other words, number. If they give you number having the same base, they may have the same power or different powers. But they need the same base. Let me apply law you. For example, A raised to the power of 4 times B raised to the power of 5. This law cannot be used because the bases are not the same. Base wọn ò the same. Tó bá ṣe pé A ló wà níbí báyìí, tí A tó wà níbí báyìí, ẹ lè ro power papọ̀ because multiplication ló wà láàrin wọn. Tó bá jẹ́ B ló wà níbí báyìí, tí B wà níbí báyìí, ẹ lè ro papọ̀. Any letter tí basis yín bá ti lè the same, power wọn tó bá ṣe multiplication o, power wọn you add them together. So that is what you have here. So instead ká máa fi kọ gbọ́ ẹ ní gbọ́rọ̀ báyìí. Yeah, A lọ́nà mẹ́ta, A lọ́nà mẹ́fà. Why can't we just say since that is the same base? A ní àwọn méjèèjì, base àwọn méjèèjì. Kí ló link wọn together? Multiplication. Ẹ wá ro àwọn power. Eléyìí ni mo pè ní power. That is this index and this index. You add them together. Ó máa fún yín ní 9. Is that clear? Now, ẹ wo àwọn example yẹn. A fẹ́ wo example tó bá law àkọ́kọ́ mu. Ṣé n pé law àkọ́kọ́ yẹn ó ní pé tá bá fi lè ní law àkọ́kọ́ yẹn ni pé tá bá ní for example a ní a raised to the power of x times a raised to the power of y. X yìí variable ni wọ́n lè fi any number síbẹ̀, ó lè jẹ́ 2, ó lè jẹ́ 3, ó lè jẹ́ minus, ó lè jẹ́ plus. The same thing fún eléyìí. Lópin ìgbà tí basis wọn bá ti the same, they have the same base. So now you just write the base, ẹ wá ro òkè yẹn papọ̀ x plus y. So law yìí, this law yẹn la fẹ́ lò ń bí báyìí. Class, ẹ wo bí báyìí o, àwọn owó ló jọra wọn. Ẹ rí pé 3 àti 2 wọn ò jọra wọn. Just bring them out. So this one would be 3 times 2. Ṣé n pé mo ti gbé jáde? Kí ló kù? Ó kù c raised to the power of 2 times c raised to the power of 5. So, here we have class. Ṣé rí pé lẹ́yìn a máa multiply wọn papọ̀, a máa fún wa ní 6. Ẹ get it? Now, ẹ rí pé lẹ́yìn c ó mì pé base mi they are the same. Màá wá ro power wọn papọ̀. So eléyìí wá jẹ́ c, á wá jẹ́ 2 plus 5. And what's now my answer? My answer is 6c raised to the power of 7. That's the answer. Is that clear? Now, ẹ wo example ẹlẹ́kejì. 4y raised to the power of 6 times 7y. Good. Bá a ṣiṣẹ́ alákọ̀ọ́kọ́ yẹn náà la máa ṣe lẹ́ẹ̀kejì. Ó yá 4 times 7. 4 times 7 times y raised to the power of 6 times y. Class, tá máa kọ ordinary y like this, ó mean pé the same thing as y raised to the power of 1. Tá bá fi lè kọ any letter tó o bá fi nǹkan kan sókè rẹ̀, the same thing as only 1 lókè. It has 1. You understand? It has 1. So this one is same thing as 4 times 7. That's 28. So eléyìí a kọ y wa. Arúpọ̀ òkè 6 plus 1. So answer is now 28 y raised to the power of 7. Is that clear? I believe it's understood. Now, the other time we dealt with multiplication. That is multiplication of two numbers that are written in what? In index form. So now, this time around, I want to derive a law for numbers that are in division form. So now, I will be by, for example, I have 3x raised to the power of 4, or sorry, let me take it this way, that is divided by 3x raised to the power of 2. Now, of one example here, that is 3x raised to the power of 4 divided by 3x raised to the power of 2. Now, everybody, you all know what the division is all about. That is 3 times x times x times x times x. Until I mean here, Abby, divided by 3 times. Remember, this is a what? This is a multiplication sign. That is, we have a division times. We have x times x times x. No, sorry. We have 2. We have 2. Now, the usual way of dividing numbers. So we have 3 cancel 3. X cancel x. X cancel x. what do we now have? We have x lọ́nà méjì, that is x squared. Is that understood? Now, let us look for a shorter way by which we can deal with this. Now, can we write it this way by saying 3x raised to the power of 4 divided by 3x raised to the power of 2. Can we now say 3 cancel this 3? Now, what about if I say x raised to the power of 4 minus 2? What will it give me? It will give me x raised to the power of 2. So in other words, when you are dividing, it means the index. That is, the index you can subtract the number from each other. Now, what are we saying? It means when you have x raised to the power of b divided by x raised to the power of c, I can now say x b minus c. Is that understood? Now, for our law, I've given you the law. What is the law? That is x raised to the power of b divided by x raised to the power of c. Only the law is what? It's saying that you just need to subtract. You are dividing. Divide, you have to subtract. Now let us now see the application here. This one now means c raised to the power of 4 divided by c raised to the power of 3. What does that give? This one now means c. Okay, we subtract. That is 4 minus 3. And what is that? It now means c raised to the power of 1. And anything raised to the power of 1 is still that thing. You understand? Okay, anything raised to the power of 1 is still that thing. Is that understood? Number 2. Thank God. What about you? So now, this one is very simple. You now say, that's 24 all over 8, y 7 all of times, or y 3. 8 here, 1, 8 here, 3. So it means we now have 3, y 7. When you are dividing, you subtract minus 3. So this one will now give us 3y raised to the power of 4. Is that clear? Good. Now, the last one, this one, linear classes. You understand? They will say 3.6 times 10 to the power of 7 divided by 1.2 times 10 to the power of 3. This one is something as 3.6 times 10 to the power of 7 all over, because this division is something as all over 1.2 times 10 to the power of 3. So 1.2 here 1, 1.2 here 3. So this one we are having 3 times 10 raised to the power of 7 minus 3. So what is now the answer? 3 times 10 raised to the power of 4. Is that clear? Very good. Now the last one, is 0 or negative power. We call it 0, or we can say 0 and what? And negative power. Now, for example, if you're given something like this, you know this one is something as y times y times y divided by, we have divided by y times y times y. Is that clear? Now this one now, y cancel this. What do you have? You have 1. So when their powers are the same, I want divide. Answer 1. Now at the same time, y using the law of indices, 3 minus 3. So what is that? So y raised to the power of 0. Now, add the proof anything raised to the power of 0 is what? Is 1. So it means when you are given number equal to raised to the power of 0, the answer is 1. 1 million raised to the power of 0, it is 1. X raised to the power of 0, it is 1. 3 raised to the power of 0, it is 1. Anything to be raised to the power of 0 is equal to 1. Only to prove it. That is, if I divide it, I get 1. Then I told the law of indices. This one still gives us a what? It gives us y. It gave us a y raised to the power of 0. So it now means that y raised to the power of 0, it is equal to 1. It's equal to 1. Is that clear? For example, we want to find another thing like this. Simplify p raised to the power of 3 divided by p raised to the power of 6. This one is same thing as p raised to the power of 3 all over p raised to the power of 6. So this one is same thing as p times p times p all over this one p times p times p times p times p. 1, 2, 3, 4, 5, 6. Now let's take our cutlass and cut. This cancel this, this cancel this, this cancel this. So look at what do you have? We have just ordinary 1. So this one is same thing as because there's nothing. So what I mean by that is 1 times 1 times 1. This is going to be 1 all over how many p loku? That is p raised to the power of 3. You understand? This is a fully expanded expression. Now, let's take our law of that indices. You know we're having division now. So this one is going to be p raised to the power of 3 minus 6. So this one will give us what? P raised to the power of 3 minus 6. That is minus 3. So in other words, I can now say p raised to the power of minus 3 is same thing as 1 all over p raised to the power of 3. Is that clear? Now, look at very beautiful example. We have examples here. One can simplify. Now, I want you to understand this. Something like this, everything is in a bracket. This minus 1 over for everything to in a bracket here. Everything to in a bracket here, only minus 1 here. But we bracket in here, see. Any to suma in yellow colony minus 1, as you are going to see here. Eric Benny by one bracket here, 1 for minus 1. Maybe by the same number now 2a. But here it was bracketed here, but it was not bracketed here. If you bracket is in by you know, bracket, maybe by one bracket. More deliberately bring this example because students usually get it confused. But I'm going to simplify it now. Let's see. Now we have this one. If you go by no bracket here, minus here, say not here. P raised to the power of minus 3 as the same thing as 1 all over PQ. So me pay 1 minus E OTT 1 here. Minus E OTT 1. So minus 11 add the 1. 1 all over 2A. Finish. 1 all over 2A. You don't have any problem. 1E all over 2A. Because minus C only, then minus C only the 1E all over P. So this is last simple times 3A squared. Class, this one is very interesting. Aleph like for by. Are you there? So yeah, let's go. This one is something as 1 times 3. That is 3 all over 2. So A raised to the power of something here. A2 raised to the power of something. So it now means A2. I told you when they write something like this, they call anything by this, raised to the power of 1. They call anything. They call 3 is something as 3 raised to the power of 1. They call Z is something as 0 raised to the power of 1. So now this one now means minus 1. And what do you now have? We have 3 all over 2. 1 from this 2. That is A raised to the power of 1. But there's only A raised to the power of 1 is same thing as what? It's same thing as A. So this one is going to be 3 all over 2A. Now what they call by? What do they call by? 3A all over 2. The same thing. Is that clear? Now, class, look at this. Check. I deliberately put it here so that I want to compare the essence of a bracket. If a bracket is income, you have to be very, very careful. and tẹ́yìn náà bá fi bracket sí nǹkan ó mean pé you must have considered it in all ramifications. So now that's why I did not rub up this. I want us to now compare the importance of a bracket. Now this one bracket. This one is same thing as 2 times 1 all over a. And get it? 2 times 1 all over a times good. Everything here owns this square. So when we put my open bracket, this one is same thing as 3a times 3a. Is that clear? So now this one now means that I have 1 times 2, top for top. This one is same thing as over 1. Top for top, bottom for bottom. So this one is going to be all over a times 3 times 3. This one is going to be 9. A meloni here. That is a squared. Good. This one is same thing as what? We multiply number together. That is 18. A squared all over what? All over a. And this one is going to give me what? That is 18. This one is a squared minus, because this one is same thing as over 1. Okay, minus 1. And this one will give me 18a. Plus, can you now see that they are two different things? I got 18a. Can you get me by 3a all over 2? I want to believe that with these examples and illustration, Timoshe, you must have understood the concept in total. Please do share this with your friends. Share it among your friends. And at the same time, I want you to subscribe to my channel. Do like the video. And please, I need your comment so that this is going to assist me in my subsequent production. Thank you.